Okay, this is the video for lesson 12, homework completion. We're going to work through these purple tabs here on the bottom of the Excel template, exercise 1 through 5. I'll see how long the first one takes. It's pretty short. I might go right on to the second one and try to make each video roughly about 5 minutes each. Okay, so this first one, the manager of Danvers Hilton Hotel stated that the mean guest bill for a weekend is $600 or less. A member of the hotel's accounting staff noticed that total charges for the guest bills have been increasing in recent months. The accountant will use a sample of future weekend guest bills to test the manager's claim. So A is, which form of the hypothesis should be used to test the manager's claim, and explain. So that's supposed to be a question mark. And explain. All right, so if we look at these, we have HO for the null hypothesis and HA for the alternative hypothesis. So this one here, the null hypothesis would be that the mean is greater than or equal to 600, which doesn't necessarily reflect the claim that the manager is making. He's making the claim that it's 600 or less. So this wouldn't be my first choice, right? So you want the null hypothesis to be what your main claim is, right? So whatever assumption that you're being made, whatever assumption that you're making, right? That's being challenged. So we're gonna look for data and challenge the assumption. If you look at the second one, this fits better. So this is the null hypothesis here, where we expect the mean is going to be less than or equal to 600. So that's what we're going to challenge. And if that ends up not being true, then we can reject the null hypothesis and go with the alternative hypothesis. All right, and then this one, U equals 600, doesn't really fit the assumption that's being made because the manager is saying 600 or less. So the middle one here is the best one. So we'll just type that over. HO is U is less than or equal to 600. So that is, let me make that a little wider. That is the manager's claim or assumption that is being challenged. Okay, and the alternative is U is greater than 600. Okay, so we'll reject the null hypothesis if we find that it's not true, and therefore basically what it means is what we find is that it's greater than 600. Okay, B, what conclusion is appropriate when HO cannot be rejected? So in that case, we are not able to conclude that the manager's claim is wrong, right? So remember during our lesson, I had said to you that we usually set it up so that we say we either can't reject the null hypothesis or we can reject. We never set it up so we say we can accept the null hypothesis. And the reason that we make that slight caveat, that slight change in the phrasing, if you would, for that particular hypothesis is so that we can kind of avoid making that type 2 error. And remember, the significance testing is what captures the probability of making a type 1 error. So we will account for that, but we're not going to be accounting for type 2 errors. So that's why we say we are not able to conclude that the manager's claim is wrong, as opposed to saying that the manager is right. I know it seems kind of trite, but that's how it's done. All right, C, what conclusion is appropriate when HO can be rejected? In that case, we'd say the manager's claim can be rejected, right? Claim can be rejected. We can conclude that the mean is greater than 600. Okay, so let's go on to the second one, and then I'll probably stop the video. Okay, so this one is a Coca-Cola example. So it's Coca-Cola Company reported that the mean per capita annual sales of its beverages in the US was 423 8-ounce servings. Suppose you're curious whether the consumption of Coca-Cola beverages is higher in Atlanta, Georgia, the location of the Coca-Cola's corporate headquarters. A sample of 36 individuals from the Atlanta area showed a sample mean annual consumption of 460.48 ounce servings with a standard deviation of 101.9 ounces. Using a significance level of 0.05 or 5%, do the sample results support the conclusion that the mean annual consumption of Coca-Cola beverage products is higher in Atlanta? Okay, so we set it up here. The reported mean, so U is 423. So we would say the null hypothesis is less than or equal to 423. And the alternative hypothesis is that people drink more than that, more than 423. So it said the sample size was 36 individuals. It said the mean sample consumption was 460.4 in Atlanta, standard deviation 101.9, 5% level of significance, and then this I calculated here. So this is just S, the standard deviation, divided by the square root of the sample size. And remember that gives you the standard error when you're working with a sample that you can use as a test statistic, which we're going to do next. So this first calculation allows us to get that test statistic. So when you're doing hypothesis testing, you take the mean on the sample and you subtract it from U, and then you divide that by SE. Okay, and that 2.2 is greater than 1.96, so it's outside, we'd say, of that area that's being captured. Remember, when you look at a normal distribution and you're looking at how many standard deviations away from the mean we are, that's what this is capturing, right? How many standard deviations away from the mean we are. We put 0 in the middle of the graph, right, in the middle of the distribution. 1 standard deviation is 1.65 away from the middle. 2 standard deviations is 1.96. That's what we're looking at here for a 95% confidence interval. 3 standard deviations is 2.58, right? So it just gets bigger the more data points that you want to capture. So here, if we're looking at a 95% confidence interval, which we are, because the significance level is 5%. So if we are, then this is, we can tell already it's outside of this z-score, right? Outside of this value for a 95% confidence interval. So but let's keep going and get this p-value so you can see how this is done. We're going to use the t-dist function. And what we put in here is the actual t-stat. The degrees of freedom, which when we have a sample size of 36, the degrees of freedom is 35, and we put true. Okay, so that's in the lower tail, right? Here we want to look at the upper tail, so we take 1 minus, whoops, equals 1 minus this, okay? And then this would give us both tails if we were looking for that. I'm going to have you do all of those every single time we do one of these because I think it's good practice. So this is 2 because you're getting both tails, so 2 times the minimum, which would be the upper tail in this case. So the upper tail is the smaller of the 2. That's giving you the outside upper tail distribution because you're looking at values that are greater than that. Okay, so because this value right here is greater than, or sorry, less than 0.05, we would say reject the null hypothesis. Okay, and we use the upper tail again because we're looking at whether or not that value here is going on the upper end of this, right? So that's on the upper tail because it's above the mean that we're looking to test. Okay, so it's in the upper tail. All right, so then here our conclusion. Atlanta customers have a higher annual rate of consumption of Coca-Cola beverages, okay, than national average. Okay, now down here I'm asking you to do the confidence interval as well so we can see what range of values would be, okay? So you use the t.inv.2t. Oops, I gotta go back and edit that. T. There we go. Probability is 0.05 and degrees of freedom, again, are 35. Okay, so confidence interval be that times the standard error, which is right here. And then we take x, which is right there, and we subtract that. And we take x and we add that. And you notice that the 432 or 423, excuse me, 423 is not in that range, right? So that makes sense too, that you would reject because this is not in the range of values that you would expect to see if this is the sample mean. Okay, so just another way of getting some information to help support your contention. Okay, let's look, let's close the video here. I think that's probably long enough, and then I'll start exercise 3 and see how many minutes that takes.